Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 7. In Chapter 1, we talked, or 7.1, we talked about the Pythagorean theorem, and today we're talking about the converse of the Pythagorean theorem. So remember, converse is like reverse, right? So the Pythagorean theorem says if we have right triangles, we can assume something, and we can use that information to like use the a squared plus b squared equals c squared to solve for missing side lengths. The converse would be if we have right triangles, what can we assume about the side lengths, basically? Or we're trying to verify whether the triangles are right triangles, obtuse triangles, or acute triangles. Okay, so we're going to be using the Pythagorean theorem to kind of verify what kind of triangle it's going to be. Okay. All right, sounds good. And the things we're talking about are acute, obtuse, or right triangles. All right, we are trying to decide for the warm-up, will the following side lengths form a triangle? See if you can remember how to do that, and we'll go over it in a second. All right, so you'll recall to form a triangle, the two smaller sides need to be bigger than the biggest side. So let's go ahead and check that. So 7 plus 9 needs to be greater than 16. What is 7 plus 9? It is 16. Is 16 greater than 16? The answer is no, so it will not form a triangle. Okay. All right, next one's a little bit tricky, but it's just kind of decimal, so let's go ahead and do this. So two smaller sides we need to add together. It needs to be larger than 5.6, which is the largest side. 2.2 plus 3.5 is 5.7. It's greater than 5.6. Is that true? It is. These side lengths would form a triangle. Okay. All right, let's talk about the converse here. So kind of like we talked about, instead of saying we have a right triangle, therefore we can like mess with the sides, this one is saying we have these side lengths, what kind of triangle will it make, okay? If it's equal to C, it's going to be a right triangle, okay? So basically, if a squared plus b squared equals c squared, it's going to be a right triangle, okay? And we'll learn about some other opportunities here in a second, okay? Let's go ahead and do an example here. So we have verify right triangles. We're going to do one, and then you guys are going to try one on your own, okay? So let's do this one down here. We have 6, 9, and 3 square root of 13. Which one looks like the hypotenuse? This one kind of looks like it's the right angle right here. We don't know, but that looks like that's going to be the hypotenuse, right? So a squared plus b squared equals c squared, right? So we're going to do 6 squared plus 9 squared equals, and now it gets a little bit tricky here. What I want you to do is put 3 square root of 13 in parentheses squared, okay? And what we're going to do is we're going to do power to a power. We're going to apply the 2 to the 3 and to the square root of 13, okay? All right, 6 squared is 36, plus 9 squared is 81. So the way you kind of do this is 3 squared is going to be 9, and square root of 13 times square root of 13. Let's review this here. What's square root of 5 times square root of 5? That equals square root of 25, which just equals 5, right? So it's kind of the same thing here. Square root of 13 times square root of 13. If you square it, it's just going to be the number itself, which is 13. If we add these together, we get 117, and 9 times 13 is also 117. So if this is true, if it's equal, if it satisfies the Pythagorean theorem, are these right triangles? What do you think? Yes, it is a right triangle. So we're going to put yes. All right, that's how you check whether it's a right triangle. Why don't you guys go ahead and do the second one? Give it a try. All right, looks like the right angle is going to be right here. So that means this is the hypotenuse. We've got A, B, and C. You could also flip A and B if you wanted to. So I'm going to do 16 squared plus 24 squared equals 29 squared. 16 squared is 256 plus 24 squared is 576 equals 29 squared, which is 841. Add these together, we get 832 equals 841. Is this true or false? It is false. It doesn't satisfy the Pythagorean theorem. So is it a triangle or not? Is it a right triangle or not a right triangle? It's going to be no, it's not a right triangle. Okay? All right. So we just kind of did one where it didn't work. And actually, even though it won't make a right triangle, it will make a different kind of triangle, which we're going to talk about in a second here, okay? So let's talk about if we get weird results. So classifying our triangle by angles using its side lengths. So here's the thing, okay? If C squared is equal to A squared plus B squared, that's going to be a right triangle, okay? If C is smaller, okay, it's going to be an acute triangle, right? The third side is a little bit smaller, it means it's going to be kind of an acute triangle. If C is larger, it's going to be an obtuse triangle, okay? So I want you to think about that here. So C smaller equals acute, and C larger equals obtuse, okay? Because remember, if C gets a little bit bigger, that means it's going to kind of create a bigger angle, which is going to make it obtuse or acute, okay? So let's go ahead and try an example. All right, we got two things happening here. We're trying to determine whether we'll form a triangle and then determine what kind of triangle it'll be, okay? So we're going to do what we did in the warm-up first. We got to see first if it makes a triangle, because it's not going to matter if we do it the other way if it's not a triangle in the first place, right? So what's the setup going to be? Well, we have 2.8 feet, 3.2 feet, and 4.2 feet. So we're going to add those together and make sure they're bigger than the third side. So 2.8 plus 3.2 is greater than 4.2. And that's going to be 6 is greater than 4.2. Is that true? Yep, so this forms a triangle. So that's the first thing, okay? It forms a triangle. The next thing we're going to do is we're going to use Pythagorean theorem, but we're going to kind of see what result we get. You'll see what I mean in a second here, okay? So we're going to do a squared plus b squared equals c squared. So 2.8 squared plus 3.2 squared. I'm going to leave a blank here. I'm going to put 4.2 squared, okay? We're not sure if it's equal, less than, or greater than or yet. We're going to figure that out, okay? So 2.8 squared is 7.84 plus 3.2 squared is 10.24. And then 4.2 squared is 17.64. Now if we add these together, we're going to get 18.08 is actually larger than 17.64. Okay? So what do you guys think? Remember, this is A, B, and C. Is C larger or smaller than the other two sides? If C is smaller, that means it's going to be an acute triangle. Okay? If it were larger, if this number was bigger over here, 17.64 were bigger, it would be a obtuse triangle. And if it's equal, it's going to be a right triangle. Okay? All right. Why don't you guys go ahead and do some choose your own adventure here. So the first ones are just checking whether it forms a triangle and or right triangle and stuff, and then the last one's kind of like what we just did. Why don't you guys pause the video and see how you do? All right, so exercises 1 and 2, we're trying to determine whether it makes a right triangle. Let's try to figure this out here. So if it's a right triangle, this is a right angle. So we're going to do a squared plus b squared equals c squared. So 4 squared plus 5 squared equals parentheses 2 squared root of 10 squared. Okay, 4 squared is 16 plus 5 squared is 25. The 2 to both of these, we're going to get 4 times 10. 16 plus 25 is 41, and 4 times 10 is 40. This is not true. Does it form a right triangle? No, does not form a right triangle. Okay, it has to be equal for it to be a right triangle. But what kind of triangle would this be? Well, if C is smaller, this is actually going to be an acute triangle. Okay, it's going to be an acute triangle. Because C is smaller. Okay? All right, let's go ahead and do number 2. Right angles right here. That's the hypotenuse. We're going to do a squared plus b squared equals c squared. So we have 15 squared plus 18 squared equals parentheses 3 square root of 61 squared. 15 squared is 225. 18 squared is 324. Do the 2 to both of these. And we get 3 squared is 9 times 61. Add these together, we get 549 equals 9 times 61 is also 549. Is this a right triangle? It is, because they are equal. Forms a right triangle. Awesome. Sounds good. All right, last example. Let's see how we do here. So we got to first see if it makes a triangle in the first place, and then we can determine what kind of triangle it makes. So the 2 smaller sides need to add and be bigger than the biggest side. So let's do that. So we got 6.1 plus 9.4 is greater than 11.3. Okay. Add these together, we get 15.5 is greater than 11.3. Is that true or false? It's true. So we know it forms a triangle. Okay. Next thing we need to do is figure out what kind of triangle it's going to make. So we're going to use Pythagorean theorem, but we're not going to put equals there. We're going to kind of see what kind of result we get, okay? So we're going to do 6.1 squared plus 9.4 squared and 11.3 squared. Leave a blank there. 6.1 squared is 37.21. 9.4 squared is 88.36. 11.3 squared is 127.69. Add these together, we get 125.57. And over here we get 127.69. Which one's bigger, the left or the right? C is bigger, so is it going to be obtuse or acute or right? It's going to be obtuse. So if C is larger, it's a larger side, right? It's going to make a bigger angle on the opposite side. That equals an obtuse triangle. That's all you got to do. I think that is it for today. It is. All right. Thank you for watching. Have a great day, and we will talk soon.